choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
I feel the liftoff. The clock has started. Roger. Godspeed, John Glenn.
Roger, 0G, and I feel fine.
This is a new and strange environment at first. This suddenly finding yourself in orbit.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Okay, Houston, we've had a problem here. This is Houston. Say again, please. Houston, we've had a problem.
Welcome home, Columbia. Beautiful, beautiful.
Discovery, go at throttle up.
Discovery, roger, go at throttle up.
Nose gear touchdown. Having fired the imagination of a generation, a ship like no other, its place in history secured, the space shuttle pulls into port for the last time. Its voyage at an end.
Hello and welcome. This is Michael Annis, and you're listening to Episode 7 of the Space Rocket History Podcast. And now, Inter-Service Rivalries. At the end of World War II, the United States seemed to be holding all the cards. They had the atomic bomb, the V-2, the research documentation, and the best German scientists. But the U.S. was rapidly demobilizing after the war. Defense budgets were being cut. The focus of the Cold War was Berlin and Stalin. Stalin controlled East Germany and Eastern Europe. He called it a buffer zone to counter any threat of invasion from the West. Stalin maintained 260 active army divisions. The U.S. had just one. President Truman's strategy at that time was to maintain a balance of forces by having the atomic bomb in reserve as an equalizer. That strategy held until the Soviets made their own bomb in 1949. It's important to understand that in the late 1940s within the U.S., there were 3 concurrent programs for military rocket development. This was due to the continuing inter-service rivalry between the Army, Navy, and Air Force. First, let's consider the Army's program. The Army preferred to think of rockets as extensions of artillery and argued on that basis that it should be given control over long-range missile development. You may recall from Episode 5, at the end of World War II, the best of the German rocket scientists had surrendered to the U.S. Army. Now I want to fill in some of the details of what happened after the surrender. Colonel Holger Toftoy was in command of the Army Ordnance Technical Intelligence Team in Paris. Toftoy realized the value of the von Braun group as well as its hardware and research documentation. He recommended that they be transferred to the U.S. In June of 1945, the U.S. Secretary of State approved the transfer. This effort to obtain the German rocket scientists was first called Operation Overcast, but was later renamed Operation Paperclip, hence the popular nickname for the von Braun team, Paperclip Scientist. But von Braun referred to his team as Prisoners of Peace. Anyway, in August of 1945, Toftoy offered von Braun and his team 1-year contracts with the U.S. Army. The contract was only offered to the most important scientists and engineers. Everyone that was offered the contract accepted, a total of 127 scientists. The first group, consisting of 7 German scientists, including Werner von Braun, arrived at Fort Strong, Boston, in September of 1945. Von Braun was quickly sent to Washington to engage in a series of meetings with military leaders. The remaining 6 members of the team, Erich Neubert, Theodor Poppel, August Schultz, Eberhard Ries, Wilhelm Hungert, and Walter Schowitzky, were taken to the Aberdeen Proving Ground to begin reviewing tons of German documents that had been transported there. Finally, all the scientists, including von Braun, were transferred to Fort Bliss, Texas, where the Army established a guided missile proving ground. The main body of the Germans arrived at Fort Bliss in December 1945 with a total number of about 100 German scientists stationed there by February of 1946. While there, they trained military, industrial, and university personnel in the intricacies of rocket and guided missiles. But the majority of their work involved time spent on the Project Hermes. Project Hermes involved the development of long-range missiles, both surface-to-surface and surface-to-air. The project intended primarily for Americanization and continued development of German technology. General Electric was awarded the contract. The following are milestones reached by the Project Hermes in the late 1940s. On March 15, 1946, the first American assembled V-2 rocket was static fired at the White Sands Proving Grounds. On April 16th, the project's first V-2 launch took place at the launch complex at White Sands as well. However, the rocket only reached 3.4 miles in altitude. Later in 1946, development began on the first new vehicle of the Project Hermes. It was called the Hermes A-1. The A-1 was a modified V-2 German rocket utilizing the German aerodynamic configuration. However, internally it was a completely new design. The A-1 was a small rocket, 25 feet tall and 3 feet wide. It was similar in design to the German Wasserfall surface-to-air missile. It was powered by a liquid-fueled engine and capable of reaching a maximum altitude of 15 miles. Maximum range was 40 miles and the maximum speed was 1,850 miles per hour. The first Hermes A-1 test rocket was also fired at White Sands Proving Ground. The Hermes A-1 is significant because the information that was gathered in the process contributed directly to the development of the Redstone rocket. In May of 1946, the first U.S.-designed rocket was launched from White Sands and reached the edge of space. It was named the WAC Corporal. That's W-A-C, Corporal. The WAC Corporal was significant because it was the first sounding rocket developed in the U.S. A sounding rocket is an instrument-carrying rocket designed to take measurements and perform scientific experiments during its suborbital flight. The WAC Corporal was liquid-fueled, 24 foot long, and 1 foot in diameter. It was launched by a solid-fuel Tiny Tim booster. Yes, I said Tiny Tim booster. It's interesting how the WAC Corporal got its name. The early U.S. rocket programs were named for enlisted ranks in the U.S. Army, such as private, corporal, and sergeant. That's where the corporal comes from. The WAC stood for Women's Army Corps. It was given this name because it was a small rocket and it didn't fit the pattern of getting bigger as you went along. In June of 1947, the bumper program was inaugurated under Project Hermes. The bumper program had 4 main goals. First, prove the feasibility of 2-stage liquid-fueled rockets. 2. Solve the problem of separating 2 rockets while in flight. 3. Prove the ignition and operation of rocket motors at high velocities and altitudes. And 4. Obtain velocities and altitudes higher than ever reached before. The bumper program used a V-2 as the first stage and a WAC Corporal as the second stage. Bumper WAC 1 was launched in May of 1948. This was the first large 2-stage rocket to be launched in the Western Hemisphere. This first combination rocket had a short-duration, solid propellant motor propelling the second stage, and the WAC attained only slightly more speed and altitude than the V-2. However, the flight was considered successful. Bumper WAC flights 2 through 4 were not successful. However, Bumper WAC 5 was launched in February of 1949. It was the first bumper to be fired with a fully fueled second stage, which allowed 45 seconds burn time. This flight was successful in every phase. 30 seconds after takeoff, the V-2 attained a maximum speed of 3,600 miles per hour, and the V-2 and the WAC Corporal separated. The WAC, with its power added to that of the V-2, obtained a speed of 5,150 miles per hour and an altitude of approximately 250 miles. This was the greatest velocity and the highest altitude ever reached by a man-made object. The nose cone was instrumented to measure temperatures at extreme altitudes. In addition, the WAC carried telemetry, which transmitted to ground stations technical data pertaining to conditions encountered during the flight. This was the first time radio equipment had ever been operated at such extreme altitudes. Although the missile had been tracked by radar for most of the flight, more than a year passed before the smashed body section was located. In May of 1949, President Truman signed a bill for a 5,000-mile test range to be extended from Cape Kennedy, Florida. The Secretary of the Army approved the relocation of the White Sands scientists and their equipment to Huntsville, Alabama. Bumper WAC tests moved to the Virgin Long Range Proving Ground at Cape Canaveral in 1950, where the rockets were intended to test staging at a near horizontal flight. These tests required a greater flight range than was available at White Sands. Bumper WAC number 8 became the first rocket launched from Cape Canaveral on July 24, 1950. This was followed by the launch of Bumper WAC number 7 on July 29, 1950, which became the second rocket launch from the Cape. Now, before we leave the Army, there is another thing that was accomplished in 1948. A V-2 was used to launch the first monkey astronaut, Albert I. He flew to over 39 miles high, but he died of suffocation during the flight. Lack of fanfare and documentation made Albert an unsung hero of animal astronauts. 3 days later, a second V-2 flight carried a live Air Force aeromedical laboratory monkey named Albert II. The flight attained an altitude of 83 miles, technically making him the first monkey in space. While he survived the flight, he died on impact. All right, now let's consider what the Navy was doing during this time. The Navy had strategic ambitions to extend their striking force to intercontinental ranges by submarine-fired missiles. In 1946, the Navy developed the Aerobie rocket. It was a modified version of the Army WAC Corporal and was continually modified and improved for decades afterwards. Also in 1946, the Navy developed the Viking rocket. It was first called the Neptune. It was based largely upon the V-2. The Viking succeeded in placing an object in space and became the basis of the Vanguard rocket. In 1947, the Navy began Operation Sandy. This involved launching V-2 rockets from ships. On September 6, 1947, a fully fueled V-2 was launched from the deck of aircraft carrier Midway. The V-2 exploded at an altitude of 5,000 feet. This led to additional tests to assess the risk of at-sea missile launches. Operation Pushover was conducted in 1948. In these tests, 2 fully fueled V-2 missiles were intentionally exploded on mock decks built to simulate at-sea launch conditions. Damage caused by these explosions were staggering, and results from these tests proved important in steering the Navy toward the development of solid fuel rather than liquid fuel ballistic missiles for launch at sea. Now let's see what the Air Force was doing during that time. The Army Air Corps was renamed the Air Force in 1947. The Air Force basically was more comfortable with the concept of long-range bombardment. The missiles had a difficult time competing with the Air Force's own enduring affection for airplanes. In 1944, the Air Force developed its JB-1 guided bomb. The JB-1 design was based on the German V-1 buzz bombs recovered during the war. Test launches of the JB-1 from both air and from the ground proved largely unsuccessful. A follow-up guided bomb was called the JB-2, and it was nicknamed the Loon. The JB-2 was nearly identical to the German V-1 buzz bomb, both in design and appearance, and several hundred were manufactured before the end of the war. The JB-2 had been destined for use against Japan, but this never happened because Japan surrendered before the JB-2 could be deployed. The JB-2 did, however, yield valuable research data. Follow-up vehicles included the JB-4 and the JB-10, all based upon the principles of the German V-1 buzz bomb. All V-1 base programs were abandoned by the Air Force in 1946. The Air Force expressed an interest in innovative missile design technologies in the late 1940s. In fact, the Air Force research resulted in the breakthrough MX-774 ballistic test missile, the great-grandfather of the modern Atlas rocket. The MX-774 was the United States' first attempt at an intercontinental ballistic missile. In 1946, Consolidated Vultee was given an Air Force research contract and began design and development of the MX-774, which led to Convair's development of the Atlas ICBM. But strategic planners were unwilling to approve the development of large, expensive intercontinental ballistic missiles that could carry the heavy nuclear bombs over a distance of 5,000 to 7,000 miles. The cost compared to cruise missiles appeared far too high, and the military leaders felt it was impractical for ballistic missiles to carry large, heavy weapons over long distances. It was not, however, beyond the capability of guided winged missiles based on traditional aircraft technology. This opinion was supported by a Pentagon study called Requirements for Guided Missiles, and that study was published in June of 1947. Of course, the Air Force was unaware the Soviets were building huge rockets they needed for ICBMs. The decision not to fund these large ICBMs gave the Soviet Union a huge head start in space exploration. It also killed the MX-774 program and directed the Air Force to develop guided wing missiles instead of ICBMs. As a result of this order, development of guided wing missiles remained vigorous, and the vehicles such as the Matador, Mace, Snark, and Navajo were created. The strategic result was that the Soviet Union had the vehicles to launch heavy payloads into space when the time came, and the U.S. was caught almost completely off guard. Also, it was well into the mid-1950s before the Defense Department came to grips with the problem of having 3 concurrent programs for rocket development run by the Army, Navy, and Air Force. Enormous amounts of time, money, and effort were wasted until the duplication and backbiting caused by the inter-service rivalries could be stopped or at least controlled. All the advantages held by the U.S. immediately following World War II seemed to have vanished. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage spacerockethistory.com and clicking on the orange donate button or the Patreon link. Thanks.